So the routing protocol RIP is one of the dynamic routing protocol. Earlier we learned OSPF. This is another protocol, distance vector routing protocol. More about the protocol we have learned in the previous class. We are here to understand how it is configured and all that we learned we are going to verify. See, in this router A, I got two networks. One is 10 network in the left, and another one is 30 network in the right. When we type show IP route, we can see that. For rest of the networks, I have written a default route which I'm going to remove now. How will you remove? Type show run and copy the line, and then go to the place where we configure static route, put no, and paste the line. This is how we can remove what we have configured. So let me repeat, whatever you want to remove, you need to go to the same place where you created it and put no in front of what you created. Now let's go back and verify. Show IP route. You see there's no static route. See, I cannot have both static route and RIP, static route and OSPF. The reason is OSPF static routes, their administrative distance are bigger than, OSPF and RIP protocol administrative distance is bigger than static route. The administrative distance of static route is only 1. Administrative distance of RIP is 120. OSPF is 110. So when you have static route will be seen always. RIP routes or OSPF routes won't come. That's why I have to remove the static route. I removed the default route which I had here. Now let me also go and remove it from router C. Show IP route. See, here also we got static default route. I said no IP route. You can copy and paste it, or you can also type it if you know. You see, I said administrative distance is 1 for static route. Whereas for RIP, it is 120. Whichever is smaller will be seen in the routing table. If static route and RIP is enabled for same network, static route will be seen. RIP routes will not be seen. Anyway, show no IP route, any network, any subnet mask, 40001. This is how we removed. See, long back we used this topology for learning static route. I'm using the same for the protocol RIP. So I'm removing static routes so that we can have RIP. See, there's no route, there's no static default route. One last router where I need to remove this static route is B. Show IP route. You see there are two static routes. No IP route 10 255 30001. No IP route 20 40. That's it. Now let me show you, it is already removed. Show IP route seats. Now there is no static routes. Let us try pinging now. The ping should not happen. What you will get is destination host unreachable. I'm going to ping the computer on the right. The computer on the right has got an IP address 20001. Ping 20001. See, I'm getting destination that you're trying to reach is not reachable. I'm receiving this message from my gateway. You see, 10.255.2.5 is this router. When I was pinging from here to here, my gateway answers saying, I don't know where to send this. His router says, I don't know where to send this. All right. So we need to enable routing protocol. Let us enable RIP now. To enable a routing protocol, you need to know about next router's network. See, router B has got 40. Router C has got 20. You don't need to know about those things. If you are an administrator of router A, you need to know the networks of router A. That's all. Administrator of router B should know about only 30 and 40. Administrator of C should know about 40 and 20. It's a big advantage. Whereas in static root, you should know the topology, you should know every network's location. Only then you can write the static route with proper direction. Dynamic routing protocol, we need to know that router where we are trying to configure. So I'm going to say to this router, you got two networks. What are they? 10 and 30. You start advertising them so that others can learn about these two networks that you have. So for that, I use RIP to advertise this. Router, RIP, network 30. This command will make the RIP to advertise these two networks. And understand, router A will not advertise about 30 towards B. You know why? Because B and A are already connected with the same network 30. So A will not advertise in the direction of B about 30 network. Only 10 network will be advertised. 10 network will be advertised saying 10 is one hop away. You want to see that? Let me show you. Simply if you wait, it won't show you. You need to type debug IP RIP. This command will show by digging deep into the conversations of RIP. This command is going to consume the buffer, the DRAM. You see, to show these things, it needs a temporary memory. If it is too much debug, then DRAM will be totally consumed. Not good. So don't do debug without examining how much it is going to consume. If you enable debug, don't forget to off the debug after you see what you want to see. Listen, router A is advertising version 1 updates to a broadcast address. Okay, to a broadcast address via F00. F00 is towards the computers. Towards the computers, it is advertising about 30 network. And towards router B, see this is the interface and IP address via which B is connected. It says 10 network is one hop. You see, it advertises the metric for the destination. Understand, it is not advertising the subnet mask because it is version 1. Version 1, I said it's a class full routing protocol. Do you see any subnet mask mentioned here, /8 or /16? No. Version 1 routing protocol will only advertise class full. So there is no need to say /8. Every industry standard operating system can understand 30 means /8. 192.168 means /C. 24/24 class C. So RIP will not send any prefix length. Prefix length is nothing but subnet mask. The length that describes how many bits given for network is what called as prefix length, the subnet mask. And to which address it will send? Version 1 RIP will send to a broadcast address. You see 255 or 255. And as I told you already, via F01, it will not advertise 30 because F01 is already connected with 30. It advertises 30 via F00. Via F01, it advertises only 10. See, this is very important to get a proper understanding about RIP. I told you there's a protocol, a rule called split horizon, which is preventing RA in advertising 30 network on F01. RA will not advertise 30 network on F01 because 30 network is on that port itself F01. Anything that is learned on F01 will not be told back on the same port is what called a split horizon rule. And I also showed you on another day, show IP F01 interface. F01, the split horizon is enabled by default. This is the command I used. Show IP interface F01. Fine. Now let me also go to router B and configure RIP. Router RIP network 40. That's all I need to know. I no need to say 10 network. I no need to say about 10 network here. They will be dynamically learned. That's why we call it as dynamic routing protocol. 30 and 40 are the two networks that we have in B. That is what I need to advertise. Likewise, I'll go to router C and advertise the 40 and 20 network which are connected to router C. Network 40, network 20. That is all. Now, in this topology here, there is no classless. You see, all are /8 class full networks. So you can have this version 1, no problem. In case if you would have configured any subnetted networks, then version 2 is what we need to enable. Right now it is not needed. Version 1 is more than enough now. Let us go and verify. Show IP protocol. It should show that you are already running RIP. See, just enabled. As I told you earlier, RIP will send periodic updates every 30 seconds, periodically. And RIP holds the root in the routing table for 180 seconds. If updates don't come, it will hold it for 180 seconds. After that, it will start advertising possibly down with metric of 16, and in next 60 seconds, which is totally 240 seconds, removes the root from the routing table. Let me show you that. Debug IP RIP again. I want to see how the 10 network is learned. In router C, 10 network is learned with a metric of 3, you see. Learning is here, this one. 10 network is received with a hop count of 2. Who is advertising this? 40001, listen carefully. This is 40001. This is advertising to this guy. This source is advertising to this guy about 10 network. And router C is learning 10 network as wait some time. Here we go. 10 network has 2 hops. From C to B is 1 hop, B to A is another hop, 2 hop, correct. And now router C is advertising the 10 network via F00, which means towards the switch. Towards the switch it is advertising as 3 hops, which is not really needed. Why should it advertise? There is no routers here. But because it is doing broadcast, it will do it. Not only that, not only broadcast, it is also a protocol which never learns neighbor. You don't know who is connected where, so it will simply send via all ports. And if there is someone to receive, they receive. If not, they discard. Now, as I told you earlier, I want to show you what will happen if 10 goes down. Right now on RB, when you check the routing table, show IP route, RB says 10 network is 1 hop away, just 1 hop. and RC will show 2 hop. 10 requests 2 hop. Now I'll go to router A and shut down that network. Or I'll do something like this. Router passive interface F00. What does this mean? Passive interface will not give any advertisement but will take advertisement. That won't suit here. Passive interface will not. I'll make F01 as passive, which means it won't advertise the network. Okay. So passive interface F0/1. When I say that router A will not advertise any routes via F01. Now, you see here, the timer. I want you to watch this timer. 18, 19, 21, 22. Every 30 seconds the update should come, okay? But the update is not going to. It is coming. Sorry, it is coming. Updates are still coming. Oh, sorry. I mean C. From C you will get advertisement. From B you will get the advertisement. I need to check in B. See the timer here. It has gone beyond 30. Router B is not receiving any update from router A regarding the 10 network because I made this interface as passive. F01 as passive. So A is not sending any update. And you see, it's 1 minute 14 seconds now. But in router C, it will receive update as if nothing went wrong. You see, 21 seconds, 22 seconds. Okay, router C. Now let me debug also. Debug IP rip. Router C is still receiving the routes every 30 seconds from B as if nothing went wrong. You see, it is receiving. Wait. I'm waiting for routes coming from 40001. It's 40002. But I want to show within 3 minutes. I don't know if this time is jumping. Okay, you see, still you are receiving as if the network is available as 2 hop. Okay, now you see we have reached 2 minutes 3 seconds. See what happens after 3 minutes. What is 3 minutes? 180 second. Show IP protocol. I told you the hold time is 180 seconds. 2 minutes 21 seconds. We are almost there. 2 hours 27 seconds. So 2 minutes 27 seconds. 2 minutes and 36, 37, 40. Just 20 more seconds. Right? So router C is receiving as if nothing went wrong. But after B, desiring as possibly down, see what happens. See 58. See, possibly down. B has decided possibly down. It will inform now to see a 16 metric. Okay, here it is 2 metric you are seeing. You look at this. 16 is an unreachable network. So to inform router C that network is no more, it uses 16. Now if you check the routing table, you will see possibly down even here. In router C also it shows possibly down. As soon as it learned 16 hop, it puts in possibly down state. How long this will be there in the routing table? 60 seconds. So 180 plus 60 is 240 seconds in total. After which the route will be removed. This should get removed in another few seconds. All right, let me stop the debug. How to stop the debug? You all. That's all. Now let us check the routing table again. Still the roots are there. 60 seconds is the maximum it will wait. Show IP protocol, you see the flash interval is 40 seconds. We saw 180 seconds to decide as possibly down. After 180 seconds, another 60 seconds is 240. It will remove the routing table, but some time from the route, the routes will not get removed unless you clear the buffer. But let's try pinging this network. This 10 network is down, right? Let us try pinging and check whether the ping happens. Ping 10.0.0.1. The ping happens with the existing route in the routing table, even though it is possibly down, it is showing the route, but in the real devices, it will get removed exactly in 60 seconds. Here, if I say clear IP route star, what does this mean? This means that refresh the routing table with the latest update. I did it. I would love to do the same on router B also, clear IP route with star. Star means all networks. I want it to be erased so that it can be relearned. It can get get into the routing table once again from fresh. So after I do this, if you check the routing table, you won't get a network. It will never come because there is no one advertising it. There's no one advertising it. Now the ping will not happen. See, destination host unreachable. Right? So this is how RIP works. Kindly ask me some questions. Right. Okay, so what next we are going to see in RIP is version 2 is a classless routing protocol. In case if you have different subnets, you need this. So what I'll do now, I'll go now to the routers one by one and make it as classless. Just one command, router RIP version 2, that's it. The default version which we enabled earlier is version 1. Router RIP version 2. Router RIP version 2. That's all. After you do this, also I would like to remove the passive interface which we configured here. I put no and I cancelled it. Now let us verify. On router A, when I type show IP route, I can see RIP has given me the route, same 2 hop, but this time it is version 2. How do I know? Let me show you all the places where you can verify this. First thing is show IP protocol. It shows that it is sending and receiving version 2. I use the command show IP protocol. It is saying it is sending and receiving version 2. Now, what address the version 2 will advertise? To multicast address, not a broadcast address. You see, debug IP RIP. This time, if you see, the address to which they advertise is 255.0.0.9. See, sorry, 224.0.0.9. 224.0.0.9. All the multicast address will start with 224 that are reserved for routing protocols. Multicast ranges between 224 to 239. If you see any number between 224 to 239 in the first octet, they are multicast address. And for RIP, it is 224.009, which is reserved. So instead of sending broadcast, it is sending only multicast. Multicast is better than broadcast. When you multicast, only the RIP enabled routers will be able to receive this packet because only for RIP this IP address 224.009 is reserved. 224.009 is only for RIP router. So when a packet says this packet belongs to 224.009, only RIP routers will open it, receive it and open it. Others won't receive it. Because the packet very clearly says this is not for you, this is for RIP routers. 224.009 is the destination address of the packet. That's what we are seeing here. See, sending version 2 update to this multicast address via this interface. Yeah. Fine. Now let me stop this debug. Another thing I want to show you here is the advertisement has got subnet mask in it. When I showed you earlier version 1 update, the mask was not mentioned there. So for example, I'm going to go and change interface F00 IP address. So this is the IP address which we already have, but instead of 8, I'm making it as 16. Two five five at 255 at 16, no? So we got our address, sorry, the mask changed to 16. Why I did this? I want to show you two things. One, RIP will do auto summarization. What is auto summarization? If it is /16, it will summarize to classful boundaries. What is classful boundary for 10/8? That is one thing I want to show you first, and then I'll show you the other one. Debug IP RIP again. You see, even though I have put /16, it is going to advertise as /8 only. Why it is advertising as /8? It is because it does RIP does auto summarization. You see, show IP protocol. Auto summarization is in effect, not in effect, not ineffective. It is in effect. If I put in and effect together, it gives different meaning. See, in space effect. Right now it is active. That's the meaning. Okay, now what is that I want to show you? I'll cancel this. Router, RIP, no auto summary. This is the command which will say do not summarize automatically, meaning show exactly the mask. Debug IP RIP again. Now let's see what it advertises. It will advertise /16. Look at this. First octet 10.255 /16. One hop away. It is sending via 30001 this interface. That makes router B to learn the subnetted network. Show IP route. You see, it has learned /16. This is vanishing. This is the old one. We just changed to classless. So the old one will vanish. See, 47. After 3 minutes, it will vanish. Or you can say clear IP route star to show the latest one. Give some time, it will come. The latest one will come. See, RIP is a bit slow protocol. You see how long it takes for learning. Every 30 seconds only they send the update. You see, you got the latest one, 10.255 is 16 mask. So auto summarization need to be disabled on the sender side. See, the receiving side is still having auto summarization. Show IP protocol. This is still having auto summarization. So let's see how RC shows you. Show IP root. RC has received /16 that was advertised. It was advertised by B. See, for router B to forward the router A advertisement, auto summarization need not to be disabled. It can be on. It's okay. Whatever router B has got in the routing table, it is going to forward. Clear IP route start. I want to show the latest. You see? What? Summarized one. Okay, we got the summarized one. Okay, which means I need to cancel here. So it was surprising that I saw 16 there. Router RIP, no auto summary. Let's see now. So let us check the latest one. So B also should say no auto summary if you want that to forward. If you want that routes to be forwarded without summarization, even on B we have to do that. No, I'm not expecting /8. Okay, good. We don't have /8. Yeah. So that's it about the protocol RIP. In our next class, we are going to move to new protocol, maybe EIGRP. Right. That is for debug. See, if you want to see debugs, we type debug, IP, RIP, and it starts showing a lot of things. And if I want to stop those things, shown in console, if I want to stop those things, I need to say undebug all. So instead of typing undebug, you just put U. See, to stop these things, you know, you can type, wait a minute, you can type U all, or you fully type undebug all. Means stop. It is to reverse. It is to stop. Mhm. Waiting for the console to get ready. Come out. Actually, I typed some slash something, so it is searching for that. Mm-hmm. All right, see, you all. U all is equal to undebug all. That will stop all the debugs. You see, debug is turned off, right?